Have you ever felt like your DAX formula just don't give you the result that you're expecting, no matter how much time you spend perfecting it? Here's the secret. It's not your formula, it's your data model. Data modeling is the key that unlocks the full potential of Power Pivot and DAX. And without it, your data analysis is only scratching the surface. So in today's video, I'm going to show you the secret behind building powerful data model that will change the way you analyze data forever. Ready to discover what you've been missing? Let's get started. Hi, my name is Lin. I'm a senior data analyst with years of experience in banking and logistics industry. Welcome back to another data analytics tutorial where we'll help Sell Poverty, a fast-growing business, analyze their messy timesheet data. In the previous videos, we've explored the basics of Power Pivot, mastered some of the fundamental DAX formula, and learned how to write advanced DAX formula. If you missed those episodes, I highly recommend starting from the beginning as we'll build up knowledge step by step. So far, we'll build a strong foundation with Power Pivot and advanced DAX formula. But now, it's time to take your skills to the next level with data modeling, the secret that ties it all together. We will be building our data model in both Power Pivot Excel's interface and Power Pivot Data Model interface. Each time, I will introduce a challenge that only a proper data model can solve. Then, we will build the data model relationship step by step, and through each process, I'll introduce the key data modeling concepts include the definition and role of each table. And finally, we'll explore how evaluation contexts behave in the data model when multiple tables are involved. Before we dive in, make sure to download the data file using the link in the description so you can follow along with me. And don't forget there's a timeline in the video description to help you to jump between sections. Please feel free to pause, rewind to follow along at your own space. And don't forget to like this video if you find this helpful. This will really help me with the YouTube algorithm. And subscribe to my channel so you don't miss out on any of future data analytics episodes. Ready to level up your data modeling game? Let's dive into it. We've previously calculated the actual holiday, sickness, and so on, but these numbers won't make any sense if we don't put them in context. So for example, the actual work days is 3,619. Is it good? Is it bad? We don't know. We need to compare this number with some benchmark to make sense of it, right? In our case, we need to compare this actual number with the planning number to see if we go above or below the planned. So let's do that. I'm gonna quickly copy this pivot table and paste it in the planning tab. Now let's kick out all the actual measure that we don't need so we can use this pivot table for the planning measure. Now the planning information is provided in the store table. We know that this is the yearly planning per employee per store. The information of number of employee, on the other hand, is located in the employees table. So how do we calculate the total store planning times while the information is gathered in multiple tables? Normally, what you would need to do is from the employees table, we look up the planning information from the store table and then make the calculation from one table only, the employees table. Or the other way around is that you would start from the store table, bring in the aggregated number of employee information per store, and then you start making the calculation from the store table. But doing like this is very cumbersome because sometimes you want to slice and dice from the store perspective, but sometimes you want to go more in detail from the employee's perspective. Now with Power Pivot, you don't need to combine all of your data into one table. You can make the connection between multiple tables. These connections are called relationships. They allow separate tables in the model to communicate with each other without the need for merging them together. In short, by connecting these separate tables together, we're building a data model in Power Pivots. You can create connection between different tables in Excel interface or Power Pivot interface. Let's start with the Excel's interface. So go to Data, Data Model, Relationship. Now click on New. A pop-up will appear showing all active tables in the data model. This will allow you to connect multiple tables using columns that share related information. Now we want to create a relationship between the employee table and the store table. How do we do that? The key here is to always start with the table that has the lower granularity, meaning the table with more row or lower level of details. In our case, that is the employees table, because many employees can work for one store. Next step is to find the related table, the lookup table, and that is the store table. A lookup table holds the unique or summarized information like IDs or name. Its main job is to help explain or match information. Think of it as a reference guide for the main table. The store table is the lookup table because it explains what the store ID means by showing the store's name and other details related to that store. And finally, we need to find the common column that connects the two tables. This is pretty easy, right? So that is the store ID column in both tables. Now you might see that there will be times the two columns name don't match exactly the same between the two tables. And that's totally fine. You just need to make sure that you select the column that refer to the same data, the same information. So to recap, the relationship that we are building here in the Excel's interface is always many to one relationship. So it is important that you understand and define the roles of the table and the lookup table up front. In our case, we have many employees work for one store. All right, now let's hit OK. And you can see that the relationship is created in the data model. Okay, now that we have the relationship created between the employee and the store table, it's time to write some DAX codes. I'm going to quickly kick out the timesheet from the active tab, add the employee, and also add the store table to the active tab. Now, in the employee table, I'm going to start writing the measure. I'm going to call this measure plan holiday. Now for the calculation, we're going to apply the same strategy like we would have done in Excel. We're going to look up the employee's holiday information from the store table, bring it into the employees table, and then sum all the results. But this time, we only use one single formula, SUMX. So type in SUMX. Now the table we want to use is the employees table. The next step is to bring the planned holiday to the employees table. So how do we do that? We're going to use related function. It's like the VLOOKUP function, but without writing the complex formula. Now, what column we want to look up? That is the planned holiday column from the store table. Now close bracket, 2 times for the related and the SUMX. Check DAX formula. There is no error. Format the number. No decimal, and hit OK. Now we have the planned holiday measure created. Let's drag it to the value area, and the measure is created with the correct results. Now for the planned workday, we're going to apply the same strategy. This time we're going to bring over 2 columns, the workday and the holiday, unless the SUMX sums the difference between these 2 columns. Check DAX formula, no error. Now format the measure and hit OK. And for the planned work hours, it's simply the multiplication between the planned workday by 8 hours. Now add these measure into the value area. And we have our planning measure created without the need for combining multiple tables together. Alright, now that we have the planned number, how do we compare this with the actual number? Let's try to compare the actual and planned holiday measure first. So I'm just going to quickly copy and paste this pivot right here. Now kick out the planned workday and work hours and bring in the measure for the actual holiday. We can see that overall, we plan 468 days of holiday, but only 448 days were taken. So who did not take their holidays? To know this, we need to drag in the employee's information, right? Let's put the employee information in the row area. And you can immediately see that we have a problem here. The actual holiday measure works fine, but the planned holiday measure does not. Why is that? Two things. There's no connection between the employees table and the timesheet table. So we need to build this connection. The second issue is that we have the employee's ID in the timesheet table. We also have the employee ID from the employees table. Are these columns different? And which one should I use? I'm going to quickly copy this pivot table, paste it right here. Now kick out the employee ID from the timesheet table and add the employee ID from the employee table so that you can compare the results between the two pivot tables. And you can immediately see here that similar issues happens with the actual holiday measure. It's repeated for all the employees. On the other hand, the planning measure works fine. Now, let's try to fix the two mentioned issues one by one. For the first issues, we need to create connection between the two tables, employee and timesheet. This time, we're going to use Power Pivot Data Model interface to do this. So let's go to Data, Data Model, and Manage Data Model. Now activate the relationship by clicking on the Diagram View button here. Here you can see the overview of all the tables that were added into the data model and its columns and all the measures attached to that table. Now you can also see that there was already a relationship created between the store table and the employees tables. This is the relationship that we've created earlier in the Excel's interface. Now we're going to create a relationship between the timesheet table and the employees table in this Power Pivot Data Model interface. Again, the same logic. Start from the table with the lowest granularity, which is the timesheet table, because one employee can work multiple days. Our lookup table is the employees table, and the common column between the two tables is the employees ID. So we start with the timesheet table, employees ID column, drag and drop the relationship to the employees ID columns of the employees table and release the mouse. And as you can see, a relationship is created linking these two tables together. Notice that there is a symbol 1 next to the employees table and a star next to the timesheet table. That indicates the direction of the relationship between the two tables, from one side of the employees table to the many side of the timesheet table. One employee can work multiple days. Again, the same logic applies for the relationship between the store table and the employees table. One store can have multiple employees. All right, now that we have our data model built, the first issue should be fixed. Let's head back to Excel to see what happened with our Power Pivot table. And you can immediately see an improvement here. Both the actual and planning holiday measures in this pivot table give us the expected results. So simply by building the data model relationship between the timesheet and the employees table, we've managed to resolve the first issue. Now, if you notice, both planning and actual holiday measures work fine when we use employee ID from the table employees as a dimension. However, when we use the employee's ID from the timesheet table to slide our data, the planning measure did not work, which brings us back to the second issue, which is the correct columns to use. To explain this, we need to come back to the basics of DAX, the evaluation contexts. This time, we will add another level of complexity, data model relationship. In the next part of the videos, we will see how the evaluation context behave when multiple tables are involved. Let's start with the actual holiday measure. We can see that this measure works when the employee's ID column comes from both employee tables and timesheet tables. Why is that? Let's take a look at what's going on under the hood of the formula. And again, let's revisit the evaluation contexts. When we use the employee ID from the timesheet table to slice and dice the data, the filter context would be internal filter come from the status column of the timesheet table is equal to holiday. The external filters from the employee's ID column of the timesheet table is equal to 1. In this case, all of the filters come from the same table, the timesheet table. And we all know from previous session, the final filter context will be the combination of internal filters and external filter. Once the filter context is formed, row context kick in and start the counts, which give us the result of 29 days. And the process repeats for other employees in the timesheet table. Now, let's take a look at the scenario where the employee ID column comes from a different table, the employees table. The internal filters remain the same, which is status is equal to holiday. The external filter, however, comes from a different table, the employees table. The filter is applied on the employee's ID column and restrict the data to employee's ID equal to 1. Now that filter context is passed along to all related table following the direction of the relationship, one to many. Therefore, in the timesheet table, the data is also filtered to employee's ID equal to 1. And the final filter context is the combination of all the filter contexts, which is the status from the timesheet column equal to holiday, and the employee's ID from the employees table equal to 1, which as a result filtered the employee's ID from the timesheet table, which also equal to 1. And finally, row context starts the count on the filtered set of data, which give us the result of 29 days. The evaluation context can only happen thanks to the table relationship we just built between the employees table and the timesheet table, which allow the information flow between these two tables. Without the proper relationship flows, these two tables cannot communicate with each other, and that's why you see the very weird results like before. Moving on to the planning holiday measure. This one is a little bit special as we're using iterator X functions, a set of DAX functions that allow you to create the evaluation context within the formula. In the previous videos, we've discussed iterator X function in greater details. I'll leave the link here so you can check it out. Now, let's see why the planning holiday measure works only when the employee's ID from the employee table is used. The internal filter is table employee, which is created within the formula by the SUMX function. Now, external filter come in also from the same table, the employees table, and we want employee's ID to be 1. So the final filter context become table employee, which contain the employee's ID, and we want the employee's ID to be equal to 1. Once filter context is formed, row context kick in. It starts pulling the planning holiday from the store table to the newly filtered table. And finally, the iterator X, SUMX, finished the calculation with the sum of the planned holiday. which give us the result of 30 days. Then the process repeats for other employees. Now, for the other scenario, where we use the employee's ID from the timesheet table, what is the evaluation context? The internal filter context is again table employee. The external filter context is now coming from a different table, the timesheet table. Although there is a relationship between the employees table and the timesheet table, the filter cannot flow against the direction of the relationship. It must follow the one-to-many direction. On top of that, the internal filters is always has priority over the external filters, and therefore the final filter context is the table employee. From that set of data, row contexts kick in, pulling the planning holiday column from the store table. And finally, the SumX performs the sum calculation on the planning holiday column of the full employees table. All of this action happens within the formula, which gives us the result of 468 days. That is the total holiday of the entire employees table. And the process repeats for other employees' ID. And this is why you see 468 days repeat regardless the employee's ID information come from the timesheet table. So to recap, the fundamental of every DAX formula is the evaluation context, which consists of filter context and row context. Filter context can be modified by DAX formula, that is called internal filter. Filter context can also come from outside of the formula, like filter, slicer, row, or column dimension. That is called external filter. When using external filter within a data model where multiple tables are involved, pay attention to the table relationship because filter can only flow from one side to the many sides. Therefore, it's best to use the one side as the filter to avoid unwanted results. Iterator X function is a special set of DAX formula that's capable of handling the creation or modifications of new filter context and row context on its own inside the formulas. Iterator X in combination with other DAX function can create powerful formulas that allow you to tailor your analysis precisely to your needs. Now we understand how evaluation contexts behave within a data model. We know which column we should use as an external filter. But the end user doesn't know that, and they might slice and die the data with the wrong column, which will result in this weird number, and that can have a negative impact on your credibility. So it's best to hide these columns completely from Excel's user interface. So let's head back to data model, relationship view. Now we're gonna hide all of the column we do not want the end user to use. So that will be the employee's ID from the timesheet table and also the store ID from the employees table. Now let's head back to Excel's and we can see that those columns are gone from the Excel user interface. The end user will no longer be able to select the wrong column. All right, now we don't need this pivot table anymore, so I'm gonna delete it and move this pivot table over here. Now we will be able to compare the actual versus planning figures to drive some insight, which we will cover in the next videos. Today, we uncover the secret to powerful data analysis, data modeling. You learned how to create relationship between tables and build a strong data model You understood the role of tables and related tables, and explore how evaluation contexts behave when multiple tables are involved. This foundation is the key to write any advanced DAX formula. Now that we've mastered the fundamental of building data model, it's time to introduce one of the most important dimensions, the date dimension. In the next video, we will explore the area where DAX truly shine, time intelligence. You will learn how to write complex time-based formula with ease, and we will also dive into some very advanced DAX techniques. Master these techniques and you will have all the tools to unlock DAX's full potential. Thank you for watching. If you found this video helpful, please give us a thumbs up and don't forget to subscribe to my channel so you won't miss the next episode in our data analytics journey. If you have any question or feedback, please leave it in the comment below and I would love to hear from you. See you in the next videos.